Okay, this is standard 70, transformations of quadratic functions. Okay, a transformation changes the position or size of a figure. Okay, there's different types of transformations, but right now all we're going to focus on is a translation. Another word for a translation is a shift, just a simple word. It moves a figure up, down, left, or right. So in other words, it shifts left, right, up, or down. Okay, so we have a parent function, y equals x squared. So this is this is called our parent function because it's going to be our original function, and we're going to talk about different translations and what it looks like to shift this specific function up, down, left, or right. So our parent function, y equals x squared, in the vertex is simply at 0, 0, or the origin. Okay, and so we're going to talk about what it looks like on graphs and on the equations to be shifted, to shift our parent function left, right, up, or down, or in other words, translate it. Okay, so down here, the blue one, throughout this video, the blue one is our original parent function, y equals x squared. The red one has been shifted, and so our new vertex is at 3, 2. So it has been shifted to the right 3 and up 2. So by the end of this video, you're going to know what that looks like if I were to give you an equation, and you're going to be able to tell me which way it was shifted and what it would look like on a graph. Okay, so important information to jot down. If a number is added or subtracted at the end of a function, this translates the function up or down. So it's going to say -3 plus 4, and you'll know to shift the function up or down. If a number is added or subtracted inside parentheses, this translates the function right or left, only it goes the opposite way. And what that means is if you see parentheses, that means the function needs to be shifted to the right or to the left, and it'll be opposite of what you're thinking. So if it's negative, it's actually going to go to the right, and if it's positive, it's actually going to go to the left, which will all make more sense when we get to examples. Okay, describe how the graph of each function is related to the graph y equals x squared, our parent graph. So the blue is our parent graph. And so my new function is y equals x squared plus 3. Again, going back to this last slide, if a number is added or subtracted at the end of a function, this translates the function up or down. So our parent function right here, y equals x squared, we added 3. So this will be translated up 3. Okay, because it's a positive 3. So this parent function is graphed at 0, 0, and so our new function will be shifted up 3, and our new vertex will be 3 units higher, so it is now at 0, 3. And that's what it would look like on a graph. So the parabola doesn't go out any, it just strictly moves up when it's when all you have is a plus 3. Okay, so the second example, we have y equals x squared minus 4, and so we know that it's a minus 4 this time, so it will now be translated or shifted down 4 units. So once again, the vertex is starting at 0, 0, and so my new red one will be shifted down 4, so the vertex will move down 1, 2, 3, 4 units. Everything else is the same and still goes on and on forever. Okay, then you're going to have functions where there's a number being added or subtracted inside of the parentheses. So going back to one of my first slides here, this bottom point, if a number is added or subtracted inside parentheses, this translates the function right or left. Okay, So because this is negative, typically we would think, oh, left is negative. It's going to shift it left. No, it's actually going to shift it right. Okay, so it's opposite once it's in parentheses. So it's going to translate, this one will be translated right 2 units. Okay, so the blue again is my parent function, and the red is going to start at the origin, and it's going to be translated right 2 units. So 1, 2, the new vertex will just be 2 units over, so the new vertex would be at 2, 0. Okay, and so this bottom one, y equals, in parentheses, x plus 1 squared. So, again, we know since it's in parentheses, it's going to be shifted left or right. And when it's in parentheses, we think opposite. So it will be translated left 1. Since we're doing the opposite, so typically positive, you would think right, but we are going to go left. So let me get the function. Okay, so here's my parabola. Starting at 0, I'm going to shift 1 unit to the left. So my new vertex is now here at -1, 0. Okay, so this last example, y equals x minus 3 squared plus 2. The same rules apply. Okay, so what's in parentheses tells us it shifts right or left, and then the number added or subtracted at the end tells us it's translated up or down. Okay, so with my number on the outside, I know that tells me that's going to be translated up 2. And then with my number on the inside, we have, well, because it's positive 2, sorry. And then on the inside of the parentheses, I know I'm going to move 3 units. And we think opposite on the inside of the parentheses. So since it's a -3, we are going to actually go right 3. Okay, and so let me get the parabola out here. So we start here at 0. It really doesn't matter which order you do them. So I'm going to go, I know I got to go right 3. So 1, 2, 3 with my vertex. And I'm going to be going up, oops, I'm going to be going up 2. So from there, I go up 2. And there's my graph. So typically you're going to be actually drawing the parabolas. It's really hard for me on this marker to make them perfect, so that's why I went ahead and just copied and pasted it. But just know that's where your vertex will move when it's being shifted. Okay, here's your U-try problems. Go ahead and take these equations and tell me, or tell your math teacher tomorrow, write down which way it translates, so it translates up, down, left, or right, and how many units, and then draw a quick graph of where it would look like. It doesn't have to be perfect, just sketch a quick graph of it. All right, then try both of these and bring your notes tomorrow for your math teachers.